Hello, everybody. Today I will talk about my experience of testing high-load stateful service for big bank, and I will share my experience, my pain, and all the lessons that we learned from this situation. So several words about me. My name is Viacheslav Aksenov. I'm a software backend engineer. Usually I write Kotlin and Java code with Spring for FinTech or some financial organizations. Also, I'm a judge of global awards and mentor in several online schools. So, what's the story? What we'll talk about today? At first, we'll talk about the architecture of the service, why the service is so complex, and why it is stateful, not stateless. Then we'll talk about testing requirements. What do we need to test it? Then we discuss the solution. So we'll talk about how did we test it, then discuss about trade-offs, benefits, and we'll think how to improve our solution. Okay, so let's talk about the architecture of this service. First of all, let's talk about our team. Our team is a full stack team of about 30 people. We have 5 backend engineers, 3 front-end engineers for Android, for iOS, and for web. Also, we have 8 manual QA engineers, as well as 5 analytics and product owner. And we have a lot of new features to implement in backlog. So let's first of all, let's consider what kind of service are we testing here. Our application is a service for filling the requisites for further processing of the payment. So when you need to pay when you need to pay, for example, for mobile phone, for the internet, maybe pay some fine, you need to fill all information about the requisite and then press just pay. Oh my God. Oh,
no problem, no problem.
Yep, little spoilers. Okay.
Take your time.
No problem. Thank you. Okay, so let's think. What is how our logic is looks like. Our service, the user need to select someone for select a payment service. Then the user need to enter requisites for first step. Like, for example, if we pay some fine, we need to enter some fine number. Then we press submit, and then the system takes some information about this fine from the fine system. The payment service add this information to the payment and provide this information to user. Then user need to enter the requisites for next step, and like, for example, contact number, and then he. User will get the new requisites for each new step. So every payment service can have unpredictable amount of steps. So after a user fill the last requisite step, he need to pass anti-fraud verification, like enter SMS code that the user is user, and then he got information about all requisites that he entered, and that system takes from other backend systems. As usual for this process, it takes about 5 minutes to enter on all steps. Like session leaves about 5 minutes. If users stop on some step and don't enter anything else and wait 10 minutes and he try to enter submit, the system tells that okay, please go please go to beginning. And you can also think that we can use the best practices for for building web services like 12 factors up, like the principles to build a good microservice. But in our situation, actually, we need to think about, we need to store information for each step, and we need to provide opportunity to go through through all process that actually include a lot of HTTP requests inside. Okay, after user enter everything, and we process the payment, and user get information that payment was success, not success, or maybe he need to come to contact with some compliance or support, and that's it. That's pretty the whole process. Okay, so let's discuss about the architecture. Why is it high load? Because we have a service and front-end client. Front-end client communicate with the service using synchronous HTTP request. The service in turn process them and responds synchronously as regular HTTP request. This system has about 1 million payments that finished per day. It means that we don't know, we cannot say how many exactly HTTP requests it handled, but it to the fine about 1 million payments finished per day for this service. So it definitely more than 3 million requests per day at least. And because this service is high load, we don't track user activity per each step. But the last step reached, as I said, about 1 million users per day, and the main question is where are the details stored in the process. I mean that we need to save information about the previous steps for the next step. And answer the details are stored in the cache that associated with the session, and it stores in memory. We cannot use any sort of database to make this system and this service stateless, unfortunately. Okay, so why is it so complicated? I think that you have this question. So after all, if you had a more advanced architecture, you would have not to deal with such complex tasks like testing the stateful service and think about previous steps, etc. And the answer is because it happened historically. The service works in large infrastructure that just cannot be quickly rebuild it or rewrite it, and we need to support it, and we need to handle with it. There's no other answers.
Or maybe banks just love overcomplicated solutions.
Oh yes, banks banks really like it. And the biggest difficulty of our task is that we cannot predict the amount of steps because it depends on other system that store information about requisites. We need to think that test must be ready processing all new information like dynamically, and the next test step depends on previous one. So we need to write complex test, unfortunately. And of course, the service must work, and the service must be stable, and new features should be implemented, and new features should not broke our service, because this service generate money, and it should be stable for users and for business. So how can we test it? Let's talk about the test requirements. When we decide how should we cover our logic, we decide that all payment types should be covered. So this service provide several types of payments fulfilling requisites. All of them should be covered. 90% of branches inside should be covered. We don't need to cover them all, because Pareto principle is 80 on 20, and we decided the last 20%, last 10% will take about 90% of our time. So we need to focus on the real task, of the task that can be solved in short period of time. And we also have a lot of integrations with third-party services inside bank infrastructure. So we decided 95 of them should be covered in our test. Other we can cover with the regular unit tests. Okay, so what we want to see in our test? We definitely want to test the entire scenario from the first step to the execution of the payment. Okay, we really want to be able to easily do a new test, and we want to add new step. We need to add new steps to test, like if we write new function, new feature in our service, we need to be able to write the new test for it pretty easily. We want to be able to manually test the script step by step and stop at each step if necessary. Also, we need isolated environment, because we need to run this test inside the CI/CD pipeline. Okay, looks complex. So what had to be solved? So we had several really difficult problems. The first one is that we need to write test the way that each next step will be depends on the previous one. We need to save information between the steps. We need to create test abstractions, and we need to handle the situation that starting the payment service can take a really long time, and in CI/CD we can start testing only when the main service is up, and it has fully initialized
Ready
context.
to accept all the requests.
Yep. Yes, and it's ready to accept and request. And also we need to containerize our tests in Docker. Okay, so how can how can we test this? Let's think how this task can be solved. We can test it manually with some CRL. Please don't make me laugh. It's not our decision. We can maybe we can test with Postman, or maybe other HTTP client, like Insomnia, Postman. Better, but still a terrible choice for this task. We can test with regular integration test. It was a good try, yeah, but it makes the test huge, poorly scalable, and very complex to understand. And for example, only one test takes about 500 of lines. It's insane. Okay, maybe we can test with Postman scripts. Yes, definitely we can, but we need to think how to run this script inside the CI/CD, and we need to add new steps, like more make it more visible, make it more convenient to add new steps. Okay, each of these options is good if you take it to test a small problem, but each of these options turned out to be unsuitable for testing our service in exactly our situation. And we came up with the following test solution. Let's decide how did we test it. We separate a service that will have only one purpose: to test the main service. It seemed the most expensive and difficult options, I understand, but it turned out to be the most advantageous in our situation. So let's think. Let's think about the architecture of this test service. Don't be scared. I will provide information about this picture. This is how the test looks. So we have a test service. We have a payment service. First of all, we need to initialize the test service. Okay, it's initialized. It is ready. Then when payment service is ready, it make a request to test service to the endpoint that okay, start the test. Payment service is launched in test profile. Then our test service make many HTTP requests for each step of payment process. Make it m times. Just depends on the setting that we set up for this test, like mocks of third-party service, and we can repeat it for every test. So let's proceed. And because the test service is completely separated from the payment service, it is possible to write it using any technology. We choose a combination of Java, Spring Boot, and we used REST Assured for a library to build each other test and assert that response is expected and or maybe provide information that assert is not expected at this step. Also, in fact, that we have singled out the service for testing into separate entity. We also have the opportunity to build any structure for describing, test. We can build any abstractions. It allowed us to create templates for each step with which we described the test, and it turned out to be simplify the structure of the tests. So we can write new tests easily, and we can easily debug business process independently as a black box. And if necessary, the collection of templates can be easily expanded with the new ones. Okay, but it sounds not very common, and yes, of course, it has some trade-offs.
So basically, instead of testing, you started with developing one more service.
Yes,
right.
Yes. and it looks like it is like over engineering. Looks like it is very complex, but let me explain. First of all, yes, it's not a secret that this solution we have chosen has its pitfalls. Let's discuss about it. First of all, we need to build another application. Yes, and it takes more time. It takes it takes people resources, and it costs really a lot of money to business. And we need to write good also we need to build business logic from the scratch for this new application. Also, there is additional service that should be maintained, and we need to maintain test service as well as payment service. Right, unit test for it. It is it's looks like our engineering, but everything everything should be covered only with the developers team, because QA engineers they cannot we cannot give them opportunity to change anything inside it, because it is a service. It's service on Java. This service is complex, and only developers know how the main service works, and how the test service work, and how to work with these two services. That's the problem. We got new service to maintain, and when we got new bugs to fix, and we had new logic to write that can be done only with the developers team. And new test can be added only with the developers team, because, as I said, it's not very common task for manual engineers to understand the Java, to add new code, to commit it to a repository, and check that it works well. Okay, but and we had to build abstractions, but it is not only like a trade-off in our situation, but also it is a bonus, because at first time when we write integration test, we have, as I said, we had about 500 lines for each test, and there were logic to prepare models, make HTTP calls, make asserts, logic for validation, for preparing the next step logic, and in the end there will result like a result assert, and it was very difficult to build internal architecture and building logic with new abstractions for test service, but on third time we've done it well, and it allows us to decrease the lines to 20 or 30 for each test, and all these lines were like our abstraction lines, not to prepare not some low-level business, not some low-level technical logic for assert for HTTP calls, but we used only high-level logic for to describe that each test. And if you solve this building abstraction task incorrectly, you will need to rewrite it, or you can get test even worse than regular integration tests. And of course, resource cost during test inside the CI/CD. Previously, we had only unit tests that were performed inside the service, and it takes about 5 minutes. But now we need to up the payment service and test service to run them in Docker Compose environment, and it takes really much more resources than in past, and only this part with the Docker Compose part takes about 15 or 20 minutes, and it costs a lot to run this step on each pull request and on each commit. And we run it only when we merge some pull requests inside the master, and for master building, this step is this step runs. Okay, and every developer should be responsible for running this this test on his own machine before he create pull request. And on local machine, it takes about 5 minutes, so significantly less than on the CI/CD agent. Okay, that was about trade-offs, but also we got some bonuses, like benefits. First and the most noticeable for the developer, it became possible to check the business logic of the processes using an automated tool. Now we don't need to up a full-fledged client from front end and click on it with your hand. Now we can just pre-register the test steps and run the script and check the correctness of the data on any step. Also, we can play the entire script locally and catch any user bug. For example, we got some bug from production that on this payment service user got some error or some bad requisite, or maybe wrong type of requisite, and you can understand what happened, what goes wrong there, and we can just run the payment service locally. We can run this test application and with debugging step by step, like mock the situation that user got on production. And we don't need testers or front-end developers to reproduce any scenario. We can do it locally with our comfortable environment for developer. The business, the most noticeable for business is according to requirements of reliability and fault tolerance. The application had to be checked by load testing, and it required the same functionality that was already available in our testing service. And after the minor modifications, we correctly managed to implement it as a full-fledged tool for load testing, and business was very happy. So we we done this task before business actually needed, and when business needed, the tool was already done. Business was really really happy that it don't need to spend more time or maybe more resources on it. And the third, rather passive but very unimportant. It became possible to fully check the operability of the payment service within the network infrastructure. Because since the service has quite a lot of logic related to cookies, sessions, headers, they also need to be tested. And it was very important, especially on the first period of life of this service. With this help of separate testing service, it was possible to check this logic as well as logic with serialization, deserialization of the data structures, and everything that depends on network and infrastructure. It also was tested with this service locally. Okay, so what lessons we got from this let me say task, complex task? How can we what the conclusion, and how can we maybe improve this functionality? How can the solution can be improved? No, it cannot be improved. Unfortunately, the architecture turned out to be too complex for this simple solutions, and also too many requirements were set for this service for testing, which did not allow us to simplify it enough. Therefore, all ways to improve the service lead to a decrease in its capabilities. And for the current situation, this solution turned out to be ideal. Therefore, I remind you once again, simple solutions are better than the complex one, and the fewer unnecessary tasks are assigned to a service, the easier it be to complete them. The third thing that comes to mind is that was a very complex architecture of this service. The more code will have to be written for each step of this life cycle. In particular, for example, if different architecture for providing details for the front client was initially chosen, the most difficult thing could be avoided, like maintaining the stateful property of the service. Therefore, every time you face some complex task, think about it. Does it really need to be solved this way, to be so complex? Perhaps it will be possible to agree and try to change of the problem statement, or correct the logic maybe of the service, and terribly reduce the complexity of the task. Maybe every time then you face a difficult task, you can think about, does it really need to be solved? Do we really need to solve this exactly task? Maybe we can just change the conditions, change the requirements a little bit, and it can save us really really lot resources for on each step. Or exactly, you can Yes, really, please keep it simple. Carefully weight the need of over-engineering. Obviously, building a separate service, the purpose of which is only to test the main one, is very complicated. And if, for example, you don't need to use such a service for for load testing, or you only have enough integration tests, then okay, do it. Don't write overly complex designs just to have them perform every function you can think of. Sometimes less is more. And that's it. That was our adventure. Thank you for your time. Thank you for passion. And if you have any question,
Thank you,
I'm happy to answer it.
Great talk. Thank you. I'll start with my questions, but I'm encourage people. You can just unmute and ask the question if you have any. So the first question that comes to my mind: did you use any dependencies inside testing service from the main app, or you completely just created isolated?
Yeah, it's a good question. On the first step, we decide to make some dependence, and it turned out to really high cohesion and coherence, and we need to. It works out bad, and we decide to make some to duplicate some logic inside test service, not not business logic, just technical one, and our test service turned out completely separated. For example, we can fully rewrite the payment service can be fully rewritten on other framework, other language, and if it has new one will have the same API and the same network dependence. I mean, for session, for cookies, we can use our test service to test it.
Okay, got it. You mentioned that in order to decrease the time in CI/CD, you decided just to make a rule for developers to run it before sending PR. But what will happen if they don't follow the rules and just push it to main branch and then it failed? How it will be solved?
Yeah, this situation happened several times. For example, some developer just make pull request that without the check without running this test locally, and when everybody checked his logic, we decide, okay, it looks fine, approve. Then he merged his pull request, and the master when master build run, it falls. It fall, and when we checked why, we figured out that it happens because of one of this integration tests, and this developer just need to fix his bug like very quickly, because master should be green every time.
Okay, Iqbal is asking, can you share insights on the reporting aspects of the testing as well? At times it happens that tester is not able to communicate the KPIs to the upper management, and it leads to miscommunication. Iqbal, maybe you can just unmute yourself and ask more detailed question, because I'm not sure I'm get the KPI part. Could you please unmute yourself?
Hi, Anton. Sorry.
Hi. Yeah. please.
So the reason of asking this question was just to get the basic understanding. So I work in an environment wherein I've experienced testers. They are not able to communicate the hurdles. Like if they are assigned a task and they uh, encounter any hurdle or an issue, they are not able to communicate to the upper management. And basically in terms of testing, for an example, there was a guy who was assigned a load testing of an newly updated gateway. And although the test results was successful, but the bottleneck was still there in the environment. So when we asked him to just give a brief about the issue which the gateway is experiencing, he was not able to communicate, or better not report it. So I am just asking, in a basic QA perspective, how can you explain to your superiors what is the basic issue and how management should rectify it?
I think I got the question. It's
Viacheslav, maybe you can explain how this QA team worked in your environment, and then maybe I'll add something.
Yes, of course. The QA team in our environment works like manual QA teams. So they open the user interface and click on the button step by step and check some make some checks that new features works very well for user. And if they found some bug, something that is broken, they tell us, and the QA team, I mean, they tell the developer that implemented this feature, and the developer can run the payment service locally, run this test service locally, and try to
replicate all these steps, right?
Replicate all the steps and replicate this bug that QA engineer found on the user interface. Usually the problem is in data, in requisite types, maybe on saving requisite logic, etc. When developers found the problem, developer fix it and check that in test it works well, and then provide this like new branch to tester, like QA engineer, and the QA engineer check that all user interface it works well. If for example there is mistake in our test service, and the QA engineer found that it really on user experience, on user interface, there is an error that not handled, not checked with test service. We need to add this new assert, or maybe like fix the test that created with error.
If I may, so to just for this particular statement, so at times I have experienced testers. Some have the mentality like if they found a bug, they will just directly report it to the superior, and that's it. Like their task, they assume like my task is only to find the bugs. And at times I have seen other testers who, when they found any test, let's say it's a minor thing. So if I just for an API, if I am providing incorrect data and I'm not getting a appropriate response, and even tester is not aware of it. Suppose in a time frame, if the predefined settings is for just a date without any time format, like 00 hours, 00 minutes, and 00 seconds, and tester is not aware that there is detailed value for it, like every to the last second. And instead of reporting it to directly to the superiors, they go to the developer, they discuss with the developer and identify what is the issue. If there is an issue with the test data or the API, then fix it. According to you, how should the approach, should a normal, uh, a, s- a decent, faithful tester should approach it? Either should he just directly report it and move on to the next task, or just investigate about it and resolve it and move to then? Because it times happens, like I myself was in a management position wherein I've experienced both kind of situation wherein testers just directly raise the issues and move on to the other task. Later it was identified that the tester was giving a bad data and he has to work on it again. So it kinds of
Okay.
like piled up the progress.
Okay. May I answer this question just from my experience? I think this is not a good idea to report everything directly without touching some bug system, because you're some kind of hiding this information and it becomes available only for you as a QA engineer and for the developer. And you are relying on developer, like he will fix it or not, how it will be fixed. So from my experience, it's not a good idea just to directly approach developer, at least if it's something really small.
Okay.
In other words, I would suggest first of all to ask for requirements. You provided an example with the date format. If QA engineer is not like confident what kind of format should be used, I think the first step is to raise this to the development team, to business analytics, to understand what is the requirement. If requirements are not like fixed, it's a bad, because user can face a lot more issues later on. So my suggestion
Yeah.
is to approach for clear requirements. If they are not clear, then you should fix first requirement, and then if requirement is clear, you should raise a bug, because bug should be somehow tracked. If it's not tracked, you may miss it easily. Thank you.
I get it. Thank you.
Yeah, I'm completely agreed with Anton, because this question is like for business processes, not like for technical system. And if you don't have any requirements from business how it should work, you just cannot verify that it works correctly because you don't know
Yeah.
how it works, how it should work. So yes, if something's wrong, you need to get information from business how it should work.
Yeah.
Yeah, it's
Thank
always
you.
very complicated in terms of processes and communication. And I believe the more mature you're as an engineer, the more you are involved in some communication issues. So if communications are set and clear, everything is more or less predictable. If they are not so defined, it can be challenging. Thank you for asking. So I believe we can wrap up. Thank you very much, Viacheslav, for the talk.